Hello there, my name's Gary Sims and this is Gary Explains. Now NVIDIA has been talking about its Superchip, the Grace Superchip, for quite a while now, and yesterday ARM announced its latest CPU core for servers in the data center. That's the Neoverse V2, and simultaneously they confirmed that NVIDIA will be using the Neoverse V2 in its new Grace Superchip. So if you want to find out more, please let me explain. Now I've got some other videos here on this channel covering NVIDIA's different announcements about its Grace Superchip. I highly recommend you go and check those out. Now this Grace Superchip with the two Grace processors on it will have 144 cores and will have 396 megabytes of cache on it, and then that can be surrounded by lots and lots of RAM. So 144 cores, ARM v9. Now the question is, what ARM v9 design is it? It's not one that NVIDIA are designing. It's definitely a Neoverse design from ARM. So just a quick refresh, ARM Cortex processors like the Cortex X1, the X2, the A710 and so on are found in smartphones and also in other mobile devices, laptops, tablets and so on. Now up in the data center, ARM have a different set of processors that are kind of based on not only the energy efficiency you get from ARM, but also the fact that you want lots and lots of cores. We're talking here about 144 cores. You want lots of caching, lots of high-speed interconnects. You want to make sure the memory interface is much more aggressive and has higher bandwidth than you get, let's say, on a smartphone, and that's their Neoverse range. And so far we've had Neoverse N1, Neoverse V1 and Neoverse N2, so 3 chips. Now the Neoverse N1 and V1 are ARM V8 architectures. So the difference between the V1 and the N1 is the N1 is designed for scaling out massively to the cloud. The more cores you have, the better. Not necessarily the fastest single-threaded performance, but more cores to handle all of that data center traffic. The V1 is aimed at having the highest single-threaded performance and not so many cores, but it also includes a much bigger and wider SVE engine, which means it's good for machine learning and for data center kind of workloads. Now we know, it has been confirmed by both NVIDIA and by ARM, that the Grace Superchip will use the new V2. So what do we know about the V2? Well, obviously it is aimed at that single thread performance. There is going to be a bump in performance, although ARM didn't give any particular uplift numbers. We know that they're focusing very much on integer performance. Although floating point performance is important, it might need to happen. Most of what happens inside of a server is integer based, and that's what you want to happen quickly. It's also, of course, got uplifts in machine learning because it's got the new SVE2 engine in it, and this one's actually 128-bit wide, and there are 4 lanes, which means it can be processing 4 SVE2 instructions of 128-bit wide at the same time. We also know that each CPU core gets 2 megabytes of private L2 cache, and that for the whole system on a die, you can have actually up to 512 megabytes of a system level cache, and that will be used for the communication between the CPU and the GPU and the network and all that kind of stuff, caching half a gigabyte of a cache on the chip itself for the system level. And talking of bandwidth and all that kind of stuff, lots of big bandwidth numbers, and importantly it supports PCI 5 and it also supports LPDDR5 and DDR5. So lots and lots of connectivity and bandwidth options for all the things that go on there in the servers. So what does this mean for consumers? Well, what it really means is that we now have ARM through the whole of the ecosystem. So down at the low end you might have a Raspberry Pi Pico. That's got an ARM microcontroller. The smartphone in your hand, whether it's Android or whether it's from Apple, is based on the ARM architecture. Laptops, Chromebooks, many of them now come with ARM processors. And now right up into the cloud, where your email is hosted, where your website is running, where the database you are using is running, whatever containers, microservices, whatever you're using, they could also be running on ARM. So it's now ARM from end to end. So this is really offering an alternative to the x86-64 world that is dominated by Intel and by AMD. Okay, that's it. My name's Gary Sims. This is Gary Explains. I really hope you enjoyed this video. If you did, please do give it a thumbs up. If you like these kind of videos, please subscribe to the channel. Don't forget you can follow me on Twitter at Gary Explains, and I also have a monthly newsletter. Go over to garyexplains.com, type in your email address, no spam, no spam, but you will get that newsletter. Okay, that's it. I'll see you in the next one.